So now that you've been exposed to a bit of Java structured concurrency concepts and an overview of some of the features, let's look at some case studies to show how to program with Java structured concurrency. And this first example is going to demonstrate the structured concurrency features that were added with new virtual thread per task executor. And we're going to use that to kind of fork off a bunch of subtasks that are going to compute primality of prime numbers again, what a surprise, in parallel, and demonstrate the features of the executor service that enhances some stuff that was there before and adds some new factor methods that support structured programming and structured concurrency. This particular approach also, just for kicks, demonstrates combining structured concurrency with Java sequential streams, just because, to be honest with you, it's so painful to write traditional Java 7 style code. So I kind of combined the two paradigms here just for fun. And you can find this in the ex2 project in my Loom folder in my live lessons GitHub repository. So we're now in the ex2 project in my Loom folder in my GitHub repository called live lessons. Here's the class we're going to look at. It's called ex2. This class is going to demonstrate one of the Java structured concurrency mechanisms. And this one's going to have a field that keeps track of random integers. And the first thing we do in the main entry point is initialize we parse the command line arguments, and then we go ahead and initialize that random integer list, generating a bunch of random numbers up to a certain number and up to a certain value. And then we go ahead and show off Java 19 structured concurrency. This particular implementation is going to use the new virtual thread per task executor, which is a new factor method that's defined in recent versions of Java, if you enable the preview mode with the executors capability. So the executors Java utility class has this new method. And it's probably also important to look at this briefly. You can see that we have enabled preview, and we've also added support for the incubator concurrency model or module, which is necessary in order to get access to some of these features. And the same sort of thing also had to have been done over here. In this case, we just do enable preview because I guess we don't actually strictly need the concurrent module for this example, but we'll need that for the next example. So let's go back over here now and take a look at what we have to do. So the first thing we do is we make a local variable called prime check futures, which is a future to a list of futures to prime results. That's a bit of a mouthful. And then we're also going to create something called GCD, compute futures, which is going to be a future to a list of futures to GCD results. So we're going to both figure out primality and greatest common divisors. And so here's the first place we use this new virtual thread per task executor feature. And you can see it goes into this try with resources block. And that means by the time we exit here, when this little block of code goes away at the bottom, all the tasks that we submit that run concurrently will be done before we can go any further. So what tasks are we going to submit in the context of this try with the resources block? Well, we're going to have two tasks. One is going to check the primality of all these random integers, and the other is going to go ahead and compute the GCDs between pairs of these random integers. And so when we say executor.submit, that will start a new virtual thread, which will then check all the primalities in the context of that virtual thread. And when we do submit down here, it'll go ahead and compute the GCDs in a different thread. So there are two different virtual threads that are running, and we'll keep track of that when we run the stuff. And you'll notice that we get back a future to this result. So check primalities is going to give us a result, and we get a future back to that. It's going to have a list of futures to prime results, and this is going to have a list of futures to GCD results, and so we end up with futures to each of these guys. And I'll take a look in a second and show you what check primalities and compute GCDs do. But then down here, you can see what we do is once we've gotten through this try with the resources block, we know everything's done or there's been an error, but let's assume it goes well. We then go ahead and say, get me the results. So for that future, for each future we have here, go ahead and get the results. And I could be more clever here and get rid of the rethrow supplier by taking advantage of these new features in Java where you can have this thing called result now. But right now we're sticking with the old way of doing things just to be somewhat more backwardly compatible for the moment. So let's take a look at these two methods that check primalities and compute GCDs. here is what check primalities does. And this also illustrates something cool. It shows that with Java structured concurrency, you can nest structured concurrency blocks. So you recall we had a block at the top over here, which is computing primalities and computing GCDs. And then within each of those methods, we have a nested block that does the same thing, but at a finer level of granularity. So down here, we're going to make ourselves a new executor service that's going to have a new virtual thread per task executor. And then we're going to take the integers. We've got this stream of random integers we're set up here. And we're going to go through this stream of random integers. And that was what was passed here as a parameter. We took a list, turned it into a stream. And we're going to map each of these things to check the primality of each number using this new virtual thread per task executor, which is a bit of a mouthful, but that's what it is. And we'll look at that in a second. And that's going to give us back a stream of futures to prime results, which we're then going to convert into a list of futures to prime results. And that's what's going to be returned here. We're going to have a list of these things that are going to come back from this. So let's go ahead and take a look at check primality. What check primality does is it uses the virtual thread per task executor that we pass in here as an executor service implementation. And it submits a task which checks to see if the number is prime, and then it goes ahead and will create a new prime result indicating the result of checking whether it's prime and the original number. So that comes back as a prime result, which is just a Java record. So that's what check primalities does. And you can see it's basically going to start a new virtual thread for each of those checks. And we could have quite a number of those. So that's what we do here for check primalities. Let's go look at compute GCDs. Compute GCDs is much the same thing. It's just a little bit more interesting. What we're going to do is, once again, make ourselves an executor service, which is a virtual thread per task executor. And then we're going to go ahead and take that list of integers and create a stream of integers, actually integer arrays, of two-element integer arrays. We're going to split the original integers list into a stream of two-element integer arrays, which are then we're going to go ahead and compute the GCD for each of these things. So we make ourselves this stream of integer arrays with two elements. We're just going to take each successive pair of elements and turn them into this stream of integer arrays. And then we compute the GCD, passing in that array and the executor. And we collect the results into a list, which will be a list of futures to GCD results. So let's go take a look at compute GCD. It follows a very similar pattern to the compute primalities method we looked at before, where we use the executor to submit a task which will compute the GCD of two consecutive integers in their little integers array. And then we'll make a new result that keeps track of the result of the GCD of those two values. So that's what that program does. Let's go ahead and run it. And you can see what it's doing. So this is going to go ahead and create a bunch of different elements. I don't think there's quite as many as we had when we were doing the thousands and millions of threads, but it's still pretty cool. And you can see what we got here. As the program is running, it's kind of printing some diagnostics, telling you what thread is being involved. And then when it's done, it's going to print the results, and you can see it tells you the results we get back are the results of the prime number check. So this prime candidate has the smallest factor of each of these different values. And the GCD results say the GCD for each of these numbers is whatever the GCD is based on that computation. And all of those computations took place in different threads, and you can assure yourself that that's what happened by taking a look at what we see here. We have these different threads, and we have the thread IDs where the work is taking place. But of course, all of those computations were virtual threads, demonstrating how we can use this approach for virtual processing. And you'll also notice that this particular example is running with a compute-bound processing model. So we're not doing I/O-bound tasks, we're doing compute-bound tasks. Virtual threads, of course, work for both I/O and compute-bound processing.